Alright guys, so we just started talking about rocks, and there's three main types of rocks. There's igneous rocks, sedimentary rocks, and metamorphic rocks. Let's start with the igneous. So the word igneous means fire formed or fire born, and that's one of the big properties of igneous rocks, is that they start out really hot. So igneous rocks are typically formed from melted rock, usually volcanic in nature. We call that kind of melted rock either lava if it's above ground or magma if it's below ground. Now, one of the things about igneous rocks is that the minerals in them are pretty evenly spread. So they have kind of this consistent look to them. It's one of the ways you can actually pick out an igneous rock. Some of them will actually have little air holes in them from gas that was escaping when they cooled. And they can have a lot of different size crystals in them, from really teeny tiny grains up to really large grains. Now, the environment that an igneous rock forms in will kind of determine what type of igneous rock you get. So some of the igneous rock forms on the surface, like from lava flows and materials ejected out of a volcano, and we call that extrusive igneous rock. And some of it is formed underground in magma chambers like we would find under here. That's a rock that we would call intrusive igneous rock because it's intruded into other rock and it doesn't actually come out onto the surface. So in our example right here of a volcano, this is the environment igneous rocks would form in. For example, the lava flows would cool relatively quickly and form one type of igneous rock. Materials ejected out of it would cool in different amounts, usually very quickly, forming other types of rock. And then the magma chambers would slow cool and form even a different type of igneous rock. Now let's take a look at a couple of those different types. First, let's look at some extrusive igneous rock, or igneous rock formed outside. So the super fast cooled stuff would usually be ejected out of a volcano. It cools so quickly that we don't actually get any crystals forming. A good example of this would be obsidian. So here's a picture of obsidian. Notice it's kind of a dark, smooth glass-like material. We don't see any crystals in it. Super fine material. Next, we have stuff that cools a little bit slower, but still really fast. Typically, we have no crystals, but when this happens, we get a lot of air holes. A good example of this would be pumice. Here's a piece of pumice. You can actually see the kind of little lines and air holes in here. And this material is really light, so you pick it up, and some of it is actually light enough to even float in water. The quick cool stuff, typically from lava flows, forms really small crystals. An example of this would be basalt. Here we have a piece of basalt. You can see lots of little bitty teeny tiny crystals in there, but overall the crystals are small and it gives it kind of just a plain gray coloration here. And then finally, your intrusive igneous rocks cool down very slowly, and this can give them really large mineral crystals. An example of this would be granite. Here's a good piece of granite. You can see those large crystals in here. Here's a crystal, here's a crystal, here's a crystal down here. The entire thing is made of relatively large crystals that formed during the slow cooling process underground.